It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farming You a Nice Coffee. Hi, this is just going to be a short video which is all about significant figures. Now, significant figures are really important when we're doing calculations for titrations because they are something that they will penalise you on if you don't use them correctly in the exam at the end of the year. So first thing I'm going to talk about is the types of significant figures. Now these are different to decimal places, so you need to make sure you're aware of that. First thing you need to understand is that any significant any zeros to the left of the numbers you're starting with are not significant. Alright, so they're not significant. And what I'll mean by that is something like 0.00365. Okay, these zeros over on this side are not significant. This overall number is given to 3 significant figures. Okay, so if we were to look at something like this though, alright, where we've got zeros on the right, okay, they could be significant. Okay, we don't know. So an example of that is something like 2000. Okay, this could be one significant figure, it could be 2, it could be 3, it could be 4. We don't know. So generally what we tend to do is err on the side of the larger one, so we would say that this possibly is going to be 4 significant figures. We don't really know though, so that one's a little bit more ambiguous, I could say. Sometimes it's not good to rely upon these ones. Generally in chemistry though, we're dealing with such small values and numbers, okay, that it's actually not something that will have with a value this big. What you could have though is something like 0.02570, and this one you would definitely say would be 4 significant figures. Okay, you would count all of these, you would not count these 2 beforehand. Okay, so that's kind of the introduction and the start to significant figures. Okay, and I'm just going to talk through some of the glassware and things that we use in titrations and talk about what sort of resolution you can read those to it, and therefore how many significant figures. Okay, so first one I'm going to talk about is a burette. Okay, so with a burette, you can, the common burette that you'll use is a 50 ml burette, and you can actually read this to 2 decimal places there. Okay, and so this is actually 4 significant figures, this burette. When you talk about reading the meniscus and recording your values here for a burette, you must always go to 2 significant figures. Okay, sorry, to 2 decimal places I should say, which will give you 4 significant figures. With pipette, pipettes that you commonly use are ones that contain 20.0 milliliters. Okay, so these ones are often to 3 significant figures, whether they're 25, 50 mil, 20 mil, 10 mil, they go to 1 decimal place, so 3 significant figures. Alright. If we're looking at volumetric flasks, volumetric flasks come in lots of different sizes here. Okay, so you could have a 50 ml volumetric flask, so it's a 50.0 milliliter volumetric flask. You could have a 200 ml volumetric flask. You could have a 1 liter also, which is 1000.0 milliliters. Okay, so volumetric flasks actually change in the number of significant figures that they have. Okay, all of them are to 1 decimal place, but this is 3 significant figures, this is 4 significant figures, this is 5 significant figures. Okay, so it just depends upon the size of your volumetric flask as to how many significant figures you've actually got. Okay, if you're talking about a mass balance, this mass balance here goes to 2 decimal places. Okay, so if you were weighing out and you weighed 8.32 grams of a substance, this would actually be 3 significant figures. Okay, if it weighed out 25.16 grams, that would actually be 4 significant figures. So in this case, the number of decimal places that your balance can go to is actually quite important. Okay, the golden rule with doing your calculations is this: always give your answer to the least accurate number of significant figures. So you might be given a question which looks a little bit like this. Alright, so you might be given a question that says you've got a solution of hydrochloric acid which has a concentration equal to 0.1024 moles per litre. Okay, you might say that that reacts with some sodium hydroxide. Okay, the average titer value was 24.56 millilitres. Okay, and the hydrochloric acid that you used, right here, you used a pipette and you pipetted out 20.0 millilitres of your hydrochloric acid. So when you're looking at this over here for the concentration, we've got 4 significant figures. Here for the volume, we've got 4 significant figures from our average titer, but here for the pipette we've only got 3 significant figures. So when we do our final calculation at the end, we would give our answer to 3 significant figures, okay, because that is our least accurate of our data. Okay, really important. Okay, final thing I'm just going to talk about is the concept of resolution. Okay, now resolution is a little bit different. Okay, resolution relies to how many decimal places you go to, really. Okay, so if you've got 2 pipettes and you've got one of them which is 20.0 millilitres and you've got another pipette that is 20.00 millilitres, alright, this one here has a higher resolution. Okay, so something with a higher resolution generally allows you to be more accurate. Okay, sometimes in the exam they might ask you about resolution and talk about ask you to talk about which student has the higher resolution. Okay, so in this case it comes down to number of decimal places. All right, and that higher resolution you have allows you to be more accurate in your calculations as well. Alright, so hopefully this has helped you out. I mean, pretty straightforward. Best thing to do when you're doing a question is just to highlight, okay, the number of significant figures you've got. So when you've got something like this, highlight your number of significant figures, write it down, and make sure you give your answer to the least accurate. Alright, remember that golden rule. Always give your answer to the least accurate number of significant figures. Hope this has been helpful. If you've got any questions, just ask. Thanks, guys.